Naguli ka namin balakid.
Good morning, grade 7 students! Okay, so please all stand and Miss Antonio, can you lead the prayer? Let's bow our head and feel the presence of the Lord. Our Father in heaven, hallowed be thy name, thy kingdom come, thy will be done on earth as it is in heaven. Give us this day our daily bread and forgive us our sins as we forgive those who sins against us. Do not bring us to the test, but deliver us from evil. Amen. Amen. So for the checking of attendance, Miss Secretary, who are the absent for today?
Ma'am, no absent for today.
Okay, very good. So, yesterday, we have done discussing about the laws of exponent. And you answered problems involving the laws of exponent. So, may I ask class, how's your activity yesterday?
Ma'am, it's okay.
Okay, very good, Miss Aganon. So, yesterday, I hope that you learned about the laws of exponent. Today, we will try to apply the laws of exponent for our next topic, which is multiplying polynomials. In multiplying polynomials, we will try to multiply monomial by monomial, binomial by binomial, and trinomial by trinomial. So, class, I hope you will listen carefully for our discussion for you to understand our topic for today. But before we start our discussion for today, I prepare some motivation. So, who are excited for our motivation for today? Okay, very good. All of you are excited because we will do a game. We will call our game as Drag and Drop. Now that you are all have a group, the instruction for the game is that you will make a graphic organizer like this. This is an example of graphic organizer, and I will give you the format of this, and I will also give you a choices wherein you will use the graphic organizer to show the solution for the multiplying polynomials, okay? Don't worry class, just use your background information or stock knowledge about multiplying polynomials because it doesn't matter if you don't know how to multiply polynomials because we will just multiply today, okay? It's not a big deal class if you encounter difficulties in multiplying polynomials. Just raise your hand, ask me what to do, and I will tell you what to do. Okay class? For the group 1, I want you to do a drag and drop of x minus 4 multiplied by 7x squared plus x minus 4. Okay? And for the group 2, I want you to do a drag and drop of 5x plus 2 multiplied by x squared plus 3x minus 4. And for the last group, I want you to make a drag and drop of 2x minus 1 multiplied by 8x squared plus 9x minus 7. So class, please use your time wisely. I will give you 5 minutes to finish the motivation for today, okay? Okay, very good. So your timer starts now. Okay class, time's up. Please pass your paper forward and choose one representative in each group to present your answer, okay? Okay, very good. So for the group 1, please come here in front and discuss what you have done. Good morning, ma'am. Good morning, classmate. So this is our presentation for our motivation for the day. So ma'am, we use distributive property since it's already organized and easy to identify. We try to multiply the first term and the second term to the second polynomial. So we have x multiplied by 7x squared. We come up with 7x cubed. X multiplied by x squared. X multiplied by negative 4, so we have negative 4x. And then we also multiply the second term of the first polynomial to the second polynomial. So we have negative 4 multiplied by 7x squared. So we have negative 28x squared. Negative 4 multiplied by x is equal to negative 4x. Negative 4 multiplied by negative 4 is equal to 16. So the final answer here, ma'am, is letter A. 7x cubed minus 27x squared minus 8x plus 16. Okay, very good, group 1. So they use distributive property to answer the graph of multiplying polynomials. So I can see that their answer is correct. Okay, very good, group 1. Now, next group is group 2. Please come in front and present your answer, please. Good morning, ma'am. The same with the group 1, we also use distributive property. So this is our presentation for our motivation. So the problem the teacher gave us is 5x plus 2 multiplied by x squared plus 3x minus 4. So we multiplied 5x to x squared plus 3x minus 4. So we come up with 5x cubed plus 15x squared minus 20x. And then also we multiplied 2 to x squared plus 3x minus 4. So we come up with 2x squared plus 6x minus 8. The final answer here is 5x cubed plus 17x squared minus 14 minus 14x minus 18. Thank you, ma'am. Okay, very good, group 2. So the same with the group 1, they also use distributive property to solve the problem given to them. Okay? So, very good, group 2, and I can see that their answer is correct. Okay? So for the last group, group 3, please come in front to present your answer. So, ma'am, we use also distributive property here. So, our problem is 2x minus 1 multiplied by 8x squared plus 9x minus 7. So, we come up with multiplying 2x to 8x squared plus 9x minus 7. So, we come up with 16x cubed plus 18x squared and negative 14x. Then we multiply negative 1 to 8x squared plus 9x minus 7. So we come up with negative 8x squared minus 9x 7. And then all in all, the final answer here is 16x cubed plus 10x squared minus 23x minus 7. So we also use distributive property here, ma'am. Okay, thank you po. Okay, very good, group 3. So also group 3 use distributive property. So all of you guys use distributive property to solve your problems. So very good, class. You have an idea about distributive property, huh? Okay, so very good for that. So for our motivation for today, you are all correct. So you are all deserve a reward. This is a chocolate. For me to know if you are all ready for our discussion for today, can I hear a who every time I say class? Okay? Class? Class, class, class? Okay, very good. So I can say that you are all ready for our discussion for today. So let's start our discussion about multiplying polynomials. Class, in multiplying polynomials, you will encounter a lot of terms including FOIL method and also distributive property. So we will apply the FOIL method and distributive property for multiplying polynomials. So now let's try to solve multiplying polynomials, specifically monomial to monomial. So when we say monomial to monomial, we are referring to the algebraic expression consisting of only one term, because from the word mono means one. Class, let's have our first example for multiplying monomial to monomial. So we have x cubed multiplied by x raised to 5. So what we will do based on our discussion yesterday about the laws of exponent. Anyone from the class? Yes, Mr. Kapinding. Okay, very good. Exactly, Mr. Kapinding. We will just add the exponent of each term with the same base. So in our problem, we have 3 and 5. So we will add 3 plus 5 is equal to 8 and copy the base. So we have x raised to 8. So that's how we will multiply monomial to monomial. So for our next example, let's try to multiply polynomials with coefficient. So we have 3x squared multiplied by negative 5x. When we say coefficient, we are referring to the number beside the variable. So we are referring to the number 3 and number 5. As you notice, class, we have different representation of multiplying. Okay? So you can make use of parentheses or you can make use of the bullet proof to do a multiplying. Okay? There is no difference between using the parentheses and the bullet proof. It's up to you what kind of multiplication operator will you use. Okay? Okay, very good. So let's continue our discussion about multiplying monomials to monomials. So what we're gonna do is we will multiply the coefficient, which is 3 multiplied by 5. So 3 times 5 is equal to 15. And then the same process on what we have done a while back, where when we will add the exponent of each term, so we have 2 and 1. So 2 plus 1 is equal to 3 and copy the base, so we have x raised to 3. All in all, we have 15x cubed. Now, let's try to multiply negative 8x squared y squared multiplied to negative 9 x y raised to 2. So, as you can see, class, we have a coefficient and at the same time, we have two variables. Now, let's just do the same method of what we have done on the last two examples. Let's first multiply the coefficient, which is negative 8 times negative 9. Okay? So, negative 8 multiplied by negative 9 will be equal to positive 72. Okay? Because negative multiplied by negative will be always equal to positive. Okay? Now, we will just add the exponent of the variable with the same base. So, let's add the exponent of x, which is 2 and 1 is equal to 3, and y, which is 2 and 2 is equal to 4. So, that's how we will multiply monomial by monomial. So, all in all, our answer or our final answer is positive 72 x raised to 3, y raised to 4. Okay? So, did you get it, class?
Yes, ma'am.
Okay. How about you have a given problem like this? A raised to 4 raised to 5. So class, what will you do? Anyone from the class? None? Okay. So class, if you see a term like this is just like a 5 times of a raised to 4. You will multiply a raised to 4 5 times, okay? It is just like example of monomial. So we will write this as a raised to 4 multiplied by a raised to 4 multiplied by a raised to 4 multiplied by a raised to 4 and multiplied by a raised to 4, okay? So we will multiply a raised to 4 5 times. Okay, so now that you already have this term, this expanded form of a raised to 4 raised to 5, you will do the same as what we did a while back. Okay, we will add the exponent of the same base. So in here, so in our problem, we have only one base. What is this? A. Okay, so we have letter A. So we will just add all the exponent of letter A. So we have 4 plus 4 plus 4 plus 4 plus 4 is equal to A raised to 20. So in here we have the solution is A raised to 20. Okay, but class, if you can see, it is very long. You will solve a raised to 4 raised to 5 very long when you use the expanded form. If you will expand a raised to 4 raised to 5. Okay? Now class, I will teach you the easiest way on how to solve this term. A raised to 4 raised to 5. Okay? So, this is very easy to solve if you really listen to our discussion yesterday about the laws of exponent. Okay, so who can give me the easiest way on how to solve like this term?
Mom!
Yes, Mr. Pinada.
Mom, I remember that you just multiplied the exponent of a to the exponent of a raised to 4, which is 4 multiplied by 5.
Exactly, Mr. Pineda. You just need to multiply the exponent of a, which is 4, to the exponent of a raised to 5, a raised to 4, which is 5. Okay, so you will just multiply 4 multiplied by 5. So that's how you will solve this problem easier than using expanded form. Okay, understand class? Okay, very good. So, very good, Mr. Pineda. Good job. You remember our discussion yesterday about the loss of exponent. So, this is our expanded form, a raised to 4, multiplied to 5 times. Then, this is our solution when we are using the loss of exponent, which is a raised to 4 multiplied by 5. So, we have in all, the same answer with the expanded form and the loss of exponent, we have a raised to 20. Okay? Understand class? Okay, very good. So, the same with this example, we have another one. We have 2 raised to 2 raised to 3. Okay? You will just multiply the exponent, but the difference here, class, is you need to simplify your solution. Okay? Not like the example a while back, you will just multiply the exponent of a and the exponent of a raised to 5. Okay? You will just add the exponent, then copy the variable, just like that. Okay? But here in our next solution, 2 raised to 2 raised to 5, we need to simplify this our solution. Okay? When you use the expanded form or when you apply the laws of exponent, you will come up with the base and the exponent. But here we have a constant term or the number 2 to be multiplied to its exponent. Okay? You understand, class? Okay, so let's try to solve this example. So we have 2 raised to 2 raised to 3. Now we will use the expanded form. We will expand this term. We have 2 raised to 2 multiplied by 2 raised to 2 and multiplied by 2 raised to 2. Add all the exponent and copy the base. So we have 2 raised to 6. Now what is the difference? A while back, we'll just copy the base and add the exponent and that's it. Now we will simplify this term, okay? We will multiply 2 by 6 by its exponent. So we have 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2 and multiplied by 2. You will multiply 2 6 times, okay? So we have 64. Okay? So that is the answer when we use the expanded form of multiplying 2 raised to 2 raised to 3. Okay? So what is the shorter way on how to solve this example? Okay? So here you can multiply first the first term, which is 2 raised to 2. You can multiply the base and its exponent, 2 raised to 2. So we have 4. Then multiply it 3 times. Okay, so we have 4 multiplied by 4 multiplied by 4. So we have 64. The same with the answer when we use the expanded form of multiplying this term. Okay, understand, class?
Yes,
Okay, very
ma'am.
good. Now, I hope that you get our discussion about multiplying monomial to monomial. Okay? So now, we will move on to our next discussion about multiplying binomial to binomial. Okay? So, here, from the word binomial, we are referring to the algebraic expression consisting of two terms. Okay, class? Because from the word bi, in binomial, it means 2. Okay, understand? Very good. So, now we have a first example. We have x plus 3 multiplied by x plus 5. So, this is an example of binomial because in every binomial, there are two terms. Okay? If we have a given two binomials, okay, so there are special product in multiplying binomials. But this time, we will just focus on our problem because we will discuss that after we finish discussing about dividing polynomials, okay? So, if our given is x plus 3 multiplied by x plus 5, so we can use the term FOIL method or distributive property because FOIL method means F, from the letter F, we define the first term. Meaning, we are finding the first term. And next is O, we are finding the outer term. Okay? And I, we are defining the inner term. And the last is L, we are defining the last term. Okay? This is how we multiply binomials. We can use the FOIL method. This is the FOIL method. This is the definition of FOIL method. So we are finding terms here in FOIL method. Okay? Now, let's how about the distributive property? Okay? So, in distributive property, we are referring to distribution of terms. So, here, we will distribute the first binomial to second binomial. The first term in first binomial distribute to second binomial, then the second term of first binomial distributed to second binomial. Okay? So, that's how we multiply binomials. You can use any of them, okay, class? You can use the FOIL method or you can also use the distributive property depending on you, okay? And also depending on what your teacher said to you, said you to use, okay? Okay, very good. So now, class, here in our example, x plus 3 multiplied by x plus 5, where are the first term? Here, x is the first term in first binomial. And also, x is the first term in our second binomial. Therefore, the first term of this problem are x and x. Okay? So, we have next, where is the outer term? We are referring to a term. Okay? We are referring to a term near the outside. Okay? Meaning, if this is our binomial, we can box it and the outer term or the term near the outside is x and 5. Okay? Okay, very good. The inner term, of course, the term inside the box. Okay? So, we have 3 and x. Okay? Understand the terms? The first, the outer and the inner. Okay, very good. So last, where are the last term on this example? So the last terms are the last term in every binomial. So we have 3 and 5, okay? So now that you already find the foils or the first term, the outer term, the inner term, and the last term, you can now multiply all the findings, okay? So let's multiply x to x. X multiplied by x is equal to, at the exponent we have, very good, x raised to 2. Then x multiplied by 5, which are the outer term, we have 5x. Then 3 multiplied by x, which are the inner term, we have 3x. Then the last term is 3 multiplied by 5, we have 15. We have positive 15. And then arrange the term. So we have x raised to 2 plus 5x plus 3x plus 15. Okay? Now, I have a question. Is this term is the final answer for the problem? Is this the final answer for the problem? Miss Kalura. Why, Miss Kalura? Why this is not the final answer for our problem?
Mom, there is still a like term 5x and 3x.
Okay, very good, Miss Kalura. If you can still recall how to add polynomials by combining like terms, now we have like terms like, as what Miss Kalura said, we have 5x and 3x. What we will do is to add 5x to 3x. So we have 8x. Okay? Any question? Yes.
Mom, why you do not add the exponent?
Class, we didn't add the exponent of, well, by adding 5x to 3x because we are adding terms, not multiplying terms. When we use the laws of exponent, adding the exponent, we are multiplying terms, not adding terms. Okay? So just add the coefficient and copy the variable. Understand, class?
Yes, Mom.
Okay, very good. So our final answer for this example problem is x squared plus 8x plus 15. Okay? So that's how you will solve binomials. Okay? So now let's try to use distributive property. If the answer using FOIL method is same, so therefore we conclude that our solution for the FOIL method and distributive property are correct. Okay? So now you need to separate the first two terms, which is x and 3, then put the second binomial. There you have x multiplied by x plus 5, then x 3 multiplied by x plus 5. So now we will distribute the x to x plus 5. We have x squared and 5x. Okay, then the same with the second one. 3 multiplied by x plus 5, we have 3 multiplied by x, we have 3x. Then 3 multiplied by 5 is equal to 15. So we have x squared plus 5x plus 3x plus 15. Then combine the like terms, 5x plus 3x, so we have 8x. Okay? Same with the answer in FOIL method, right? Now, what does it mean? We have a x squared plus 8x plus 15, the same with the answer with the FOIL method. What does it mean? Miss Quello, what does it mean?
Mom, in multiplying binomials, you can make use of either FOIL method or distributive property.
Okay, very good. Because you will come up with the same answer. Okay, so very good, Miss Quello. Now let's have the second example. I will use distributive property in this answering this kind of binomials, okay? Because it is easier than FOIL method, okay? So we have 2x multiplied by 2x plus 5 and negative 5 multiplied by 2x plus 5. Okay, we use the distributive property. So we have then 2 multiplied by 2x multiplied by 2x, we have 4x squared, then 2x multiplied by 5, so we have 10x. Then the same with the second term, we have negative 5 multiplied by 2, 2x is equal to negative 10x. Then negative 5 multiplied by positive 5, we have negative 25, okay? Then combine the like terms, we have the positive 10x and the negative 10x, it will equal to 0. You can cancel out the positive 10 and negative 10 because when you add this term, you will it will come up to zeros, okay? You can just cancel it already, okay? So we cancel out 10x and negative 10x, so we have 4x squared minus 25. Okay, that is our final answer for these two binomial. Okay, class, can you try to solve this one in FOIL method to prove that our answer is correct? Okay, can you do that, class? Okay, very good. So I will give you maybe 3 minutes, 2 minutes or 3 minutes to answer this problem. Okay. Okay, good luck, class. Okay, who can say the final answer for this problem?
Ma'am,
Yes.
same answer with the first example.
Okay, see? We have the same solution, so that we conclude that our problem was, our solution in using distributive property in this problem is correct. Okay? Very good, class. Now, class, are you in there? Are you still there? Are you still listening?
Yes, ma'am.
Yes, I hope so because we are very have a lot of examples, right? And I want also to know if you are still listening here. Okay, very good. So let's continue. Can we continue now? Understand the examples?
Yes, ma'am.
Okay, very good. So now, let's talk about multiplying polynomials. Okay? Let's say, let's try to multiply monomials to polynomials with more than one terms. Okay, class? Okay, so let's have the first example. 3x multiplied by x squared minus 5x plus 7. Okay? Here, class, we have monomial which is 3x and trinomial which is x raised to 2 negative 5x plus 7. Now we will just apply the distributive property and follow the rules in multiplying monomial by monomial. Okay? Did you get it, class? Okay, very good. So now let's distribute 3x to x squared minus 5x plus 7. Then 3x multiplied by x squared is equal to 3x cubed. Then 3x multiplied by negative 5x, so we have negative 15x squared. And 3x multiplied by 2 is equal to, multiplied by 7 is equal to 21. Okay? So this is the final answer of our problem. Class, the easiest way to solve monomial to monomial, which is more than 2 terms or 1 term, is to use distributive property. Okay? So now let's try another example. We have negative 5x squared y cubed multiplied by 2x squared y minus 3x plus 4y raised to 5. Class, this is also an example of monomial to trinomial, okay? So just distribute negative 5x squared y cubed to 2x squared y minus 3x plus 4 raised to 4y raised to 5. So we have negative 5x squared y cubed multiplied by 2x squared y. Class, based on our example in multiplying monomial, what we will do here?
We will multiply the coefficient negative 5 times 2.
Okay, very good. So here we have to multiply the coefficient negative 5 to 2. Okay, so it's equal to negative 10. Then x multiplied by, then add the exponent of x. We have 2 plus 2 is equal to, copy the base, x raised to 4. And then the y, 3 plus 1 is equal to y raised to 4. So we have here negative 10, x raised to 4, y raised to 4. Okay? Next, let's distribute naman negative 5x squared y cubed to negative 3x. So we have negative 5. Just multiply the coefficient of the same term. So we have negative 5 multiplied by negative 3 is equal to positive 15. Then add the exponent of x of the same base. We have x squared plus 1 is equal to x raised to 3. Then copy the other variable because y doesn't have the same base, so it's only y cubed. So we have 15x cubed y cubed. Okay, and for the last term we have negative 5x squared y cubed multiplied by 4y raised to 5. So it multiply the coefficient negative 5 multiplied by 4 is equal to negative 20. Then x squared, then y raised to 3 plus 5. So it's equal to y raised to 8. So we have here negative 20 x squared y raised to 8. Okay, class? So you see, class, it will become easier for you to solve any kind of multiplying polynomials if you have an idea of using distributive property, FOIL method, and also the most important is if you know how to use or how to solve the laws of exponent. Okay? For the last example, I want to solve trinomial to trinomial under the example of multiplying polynomials. So we have x squared plus 3x minus 4 multiplied by 4x cubed plus 5x minus 3. So this is very time consuming, class, because it has a very long solution. That's why I will just give you one example of multiplying trinomial. Okay, but don't worry, class, we will just use distributive property, and if you understand our past discussion, you can solve this even without my example. Okay, so now let's distribute the terms in the first trinomial to our second trinomial. So the first term is x squared distribute to 4x cubed plus 5x minus 3. Okay, and then the next term in the first trinomial is 3x distribute to or multiply to 4x cubed plus 5x minus 3. And then the last term for the first trinomial, we have negative 4 multiplied by 4x cubed plus 5x minus 3. Now let's try to solve the first distribution of this multiplying trinomial. So first we have x squared multiplied by 4x cubed plus 5x minus 3. So can you solve this, Mr. Kagembal?
Ma'am, x squared multiplied by 4x cubed is equal to 4x raised to 5. Then x squared multiplied by 5x is equal to 5x raised to 3. And x squared multiplied by negative 3 is equal to negative 3x raised to 2. Ma'am, that's the answer.
Okay, very good. Exactly, Mr. Kagimbal. So next, how about Mr. Adawag? Can you solve the second distribution?
Ma'am, 3x multiplied by 4x cubed plus 5x minus 3 is equal to 12x raised to 4 plus 15x squared minus 9x. So that's the answer, ma'am.
Okay, very good, Mr. Adawag. Okay, so next, how about the last distribution or the third distribution, which is negative 4 multiplied by 4x cubed plus 5x minus 3. Can you solve this, Miss Sumawang?
Negative 4 multiplied by 4x cubed is equal to negative 16x cubed. Negative 4 multiplied by 5x is equal to negative 20x. And negative 4 multiplied by negative 3 is equal to 12. So that's the answer for
Okay, very good, Miss Sumawang. All of you already know how to solve multiplying polynomials, because even we are multiplying trinomials to trinomials, you can already answer it. But the solution for distribution of first term, second term, and third term, it's not the final answer. Okay, so for the final answer, I want you, Mr. De Guzman, to answer the last part of our discussion for today.
Mom, we will organize all the solutions we got, then we will see if there are more that can be combined or so-called like terms. Then let's combine the like terms, and that we will our final answer, ma'am. In this case, we have 4x raised to 5 plus 5x cubed minus 3x squared plus 12x raised to 4 plus 15x squared minus 9x minus 16x cubed minus 20x plus 12. So we have like terms of 5x cubed minus 16x cubed, so it will be equal to negative 11x cubed, and 3x squared plus 15x squared is equal to 18x squared. And also we have also like terms of negative 20x minus 9x is equal to negative 29x. So let's organize again the solution for the largest exponent to constant term. The final answer is 4x raised to 5 plus 12x raised to 4 minus 11x cubed plus 18x squared minus 29x plus 12, ma'am. So that's the final answer, ma'am.
Okay, very good, Mr. De Guzman. So, Mr. De Guzman answered the problem correctly and explained it perfectly. Okay, so the final answer of Mr. De Guzman is 4x raised to 5 plus 12x raised to 4 minus 11x raised to 3 plus 18x squared minus 29x. Minus 29x plus 12. So, very good, class. So, any question, class? Okay, very good. Now, I hope that you understand our discussion about multiplying polynomials. I give you a lot of examples, so I hope that you all listen and I hope you learn, okay? I will give you an activity, okay, guys? Who are they excited for an activity? Okay, raise your hand. I know that no one is excited because there's activity again. A lot of activity for Ma'am Andrada. Okay? But no, activity is for you guys to practice if you are ready to multiply polynomials. And I see that you are all ready, and because you participate in our discussion a while back, you give your yung ideas, right? Okay, so let's have our activity for today. Our activity for today, it's only 5-item quiz. You will solve problems involving multiplying polynomials. Don't worry, class, it's very easy. It's just a practice drill for you because you already know how to multiply polynomials, right? Okay, so these are your activity for today. For the number 1 up to number 5. Please answer the following activities problems in just 5 minutes and pass it to me, okay? Okay, very good. Take your time, class. If you are all done answering the activity, please pass the paper forward. The time is up. Okay, so pass the paper forward, guys. Okay, for the last part of our discussion for today, I want you to make an formative essay consisting of only one paragraph, okay? Only one paragraph discussing how to multiply polynomials. This will serve as your evaluation and generalization of our topic, okay? so that I can make sure that you are all listen in our discussion. You understand what I'm saying, you know. Okay, so please prepare a one whole sheet of paper and make a one paragraph essay about how to solve multiplying polynomials step by step, okay? And pass it later. And that's all for today, class. And I hope that you gain a lot of knowledge from me. Always remember John 8 verse 32, you'll know the truth and the truth will set you free. Goodbye, class!